3i, scientific notation. Scientific notation is a method of taking large or small numbers, lets us write it in a standard way so that it's less tedious to write, less prone to error, and less difficult to say. And let's take a look at some large numbers. 322 million meters per second. To write this in scientific notation, what we'll do is move the decimal place so that there's a single digit in the one spot. That will make 3.22. I think you'll agree that 3.22 is not equal to 322 million. What we'll now do is multiply by 10 so that we get to our original value, which will be times 10 8 times. 3.22 times 10 8 times does not make this easier to write. What we'll do now is take the tens and write them as a single power. 3.22 times 10 to the 8 meters per second. You'll quickly learn that the positive exponent is just simply the number of spaces that the decimal needs to move to the right to return the number to its original value. Let's take a look at a small number, 0.000000753 grams. Again, what we'll do is rewrite this so that there's a single digit in the one spot, 7.53. Again, 7.53 does not equal our original value, so in this case, we will divide by the number of tens to return it to its original value. In this case, it's 7 tens. We can now rewrite the tens as a single power, 7.53 divided by 10 to the power 7. If you remember from previous lessons, we can move the 10 to the power 7 from the denominator to the numerator by changing it to a negative exponent, 7.53 times 10 to negative 7 grams. You'll also learn that if it's a negative exponent, it is simply the number of spaces the decimal needs to move to the left to return it to the original value. Another little shorthand trick is to count the number of zeros in the original decimal value. That would be our negative exponent.